All right. Well, I want to talk about the current ODP, which is due tomorrow morning, and want to talk about anything anybody wants to discuss regarding PA3, and then we're going to talk about class extensions and start playing with some more windowing stuff from Swing and Window Builder. But any questions up front? Anything you want to go over first?
Okay, quick question on P3. More
Mm-hmm.
structure question. Um, I have obviously all three classes, but had made a comment last week about how the tree class is going to be mostly wrappers around the node class.
In some cases, yeah.
Okay, because in my case, the node class, builds a node, has a constructor in there for it to initialize the object, but the tree class is the real workhorse of
Okay.
my program. But it all works and everything functions with the three classes. And obviously, I have the PA3 to kind of run the program and do the operations that are needed
Mm-hmm.
as the main program. But you're basically just making sure that it works and that everything is there and nothing's weird about it, right? Kind of deal.
Yeah, I'm not going to critique you on what you put in what class or what you called your methods or how you tied them together or anything like that. Mostly,
Okay.
I'm going to play the game a bunch of times, and if everything works the way it's supposed to, then I'll go ahead, look at the code, and just kind of make sure there's comments and that you implemented a tree and so on and so forth.
Okay.
Can I can I encapsulate the node class inside of my decision tree because it's like so general purpose?
Mm-hmm.
Okay.
Yeah, that's fine.
Yeah, I think my node class has the constructor and then a print method that I end up commenting out because I didn't need it after I tested it.
Okay, so you did the traversal for writing out the file. You did that in the tree class?
Yeah, that's all in the tree class.
Okay, cool.
Because I found it easier to pass the file from the main program to the tree
Mm-hmm.
instead of trying to pass it to three or pass it to the tree and then from the tree to the node.
Right. Okay, cool.
Did all that in the tree.
That's totally legit.
I will say there was an aha moment where I actually got it to write to the file. I
Mm-hmm.
don't have a lot of experience with print writers,
Mm-hmm.
so it took some forums to figure out exactly what was needed.
Okay.
But it's kind of cool once you get it to work and you realize everything you need is. It's a pretty cool little program.
Cool. Awesome. Yeah, and print writers are a nice class. There's so many different ways to do I/O in Java, and it comes at lots of different levels of human readability versus binary. Print writers are just the one I've been using in this course the past few years because they don't really need a lot of extra stuff. You can construct them with a file name and then just use them like you use system.out. But they're definitely not the only game in town.
I think that's like one of my favorite things about Java so far in comparison to some other languages I've seen. I like Scanner's a real cool class.
Yeah,
Or
yeah.
print writer too.
Mm-hmm. Scanner does a lot of stuff we haven't played with.
So I had to use a file writer alongside the print writer
Hmm.
to get it to work.
Should not need that. It's okay if you did that, but that should not be needed.
Okay. Maybe we'll cross that bridge in a week or so. I'll ask you about that after the
Okay.
project's done.
Cool. All right, good. Other questions? All right, well, let's talk about ODP 306. So this is basically a continuation of 305. 305, you had a pair of states in your class, Actually, let's go ahead and take a look at some code for 305. So 305, your class was called states, and there were two states, addition and multiplication. The default state is addition, an internal running result, which initializes at 0. A pair of methods for changing your state. So do add, I just set my state to 1, which means add. Do mul, I set my state to do, which means 2, which means multiply. And then process, which basically, depending on the current state, either adds your number to the result or multiplies the result by the number. And then a result method that just returns the value of that running result. So that's 305. 306 just kind of extends that. Same idea, but with 4 states. So you have the result method for returning the current result, process for operating some number against the result, but now a do-op command which takes 4 different arguments, add, sub, mul, and div, and those will place the system into one of 4 states. And then depending on what state you're in, process will either add, subtract, multiply, or divide n with the result. And the one slightly subtle thing here is for subtraction, make sure that subtracts the number n from the result. Right? Subtraction is not commutative, neither is division. So subtract n from the result or divide the result by n. And then add and mul are the same as...
Not to cut you off, but I was really confused on that void. I thought that was a 0 in do. So it was like giving me 0 out of 10s, but I was
okay.
So
Okay.
it was a 0, but it's actually a capital O.
Yeah, so that's do operation. I should call it something different.
It's funny. I put results with an S, and it kept giving me 0.
Ah, yeah, yeah.
I had to go back and look, and I wrote my main program and go, oh, it's calling result.
Mm-hmm. Yeah, it's the subtle stuff that'll get you sometimes. Alright, so everybody got a good handle how to do this if you haven't done it already? Really the only thing that changes is process, which now works on 4 states instead of 2. And instead of having an add and a mul method, you have a single do operation method. And just update your state variable. All right. Well, let's and any other questions on PA3? I had a full house in office hours this morning, and it was largely people trying to do things differently from what I've suggested in class, particularly the ingest method. To ingest the file into a tree, you don't read the file line by line and build a tree like we do with binary search trees. It's a totally different algorithm because we're trying to build a tree from a file that's been written node left right. So the usual approach doesn't work. How many classes do you recommend? So I think I did like a main class, a tree class, and a node class. But you may get away with fewer. You may find a use for more. But you could start with that, and if it feels like you don't really know what to do with this class, toss it. If it feels like I've got 2 different things going on in this class, split it into 2 different ones. And PA4, I'm not going to tell you anything about what classes to make. So that's going to be an even bigger exploration of how to design a project in terms of breaking it into classes. So feel free to explore that space.
You can almost think of like the node class as just like a struct, and it's some languages you don't even have that keyword class. You just have, or keyword struct. Yep, just class.
Mm-hmm.
And that's what you might use it for.
Yeah, so if you're not putting methods in there and such, it's really just holding data.
It's like my node structure.
Mm-hmm. Right, right. All right, well, let's move forward. Let's talk about class extensions. And so, you've heard me mention that, you know, part of object-oriented design is about code reuse, not having to reinvent the wheel, and having packages of classes is one way that, you know, if we want a linked list, we just use the linked list class, right? We don't have to write the code for a linked list. Generics are another thing that support code reuse because you can write a set of code that's kind of agnostic to what sort of data it's working with. Another nod to code reuse is class extensions. And so the idea is we defined a rectangle class, and we had some areas in there for some methods in there for area, and some methods in there for perimeter, and you know there's the height and width, and so on, and that's a good general purpose class. Suppose you wanted to make a class that only managed squares. You wanted to make a new class called square, and it would look almost exactly like a rectangle, except the height and the width would be the same. You would construct with a single argument, and you wouldn't be able to change, you know, the height without changing the width, because they're always the same. It's a square. So one option would be to take all the code inside rectangle and rewrite that in your square class. But there's a different way we can do this. We could say class square extends rectangle. And as soon as we say that, effectively all the code inside a rectangle is now part of a square. So it inherits all of the methods, all of the fields from the rectangle class into the square class. Yeah, there are lots of different terminologies.
So when you say that, does that mean that you can call square and then a method that was actually inside rectangle, like area?
Exactly. So if I construct a square, I could say square.area, and it will run this code from the rectangle class.
So the only difference would be you would probably want to build a constructor for the square,
Mm-hmm.
and then everything else is already extended.
Exactly.
Okay, that's cool.
It's like toString also, where if you make your own custom class, you gotta override toString. You could override area in this case, where you could just have like maybe there is a length and a width, but you just want to multiply the length by the length in
Mm-hmm.
area. You could override that method.
Yeah. So let's do that. So here's our handy rectangle class, and class rectangle has a height and a width, and it's got a constructor that takes a pair of arguments, height and width, and let me change this. We'll come back to what just happened here in a minute. Alright, so it's got a pair of constructors. A constructor that takes two arguments, which sets the height and the width to the 1. And maybe there's a default constructor which says, you know, let's just initialize this to a 1x1 square or something. It's got a toString method which says, you know, a something by something rectangle. It's It's got an area method, which returns the product of height and width, and a perimeter, which is twice the sum of the height and the width. And so that's our rectangle class. And if we make a main method, we could say something like rectangle r equals new rectangle. And then we could you know, print out what r is. Yes, didn't I fix that? Alright, so r is a 1 by 1 rectangle. And, you know, obviously if I construct this differently, I can make a 3 by 5 rectangle, and it'll tell me r is a 3 by 5 rectangle. Alright, so let's make a square class. So I'm going to say class square extends rect. Alright, so let's make a constructor, and we're going to construct a square by just passing in one side. Well, I'm going to build this by saying height equals width equals side. And that's my constructor, and that's my whole square class. Now, I don't have height and width defined inside here. But because I'm extending a rectangle, and a rectangle has a height and width exist inside the square class. They were inherited from the rectangle class. So if I compile this, that should compile just fine. And now if I go back to my main program, I could say let's make a square S, which is a new square. And we'll make it a 5 by 5, and let's print out what our square S equals. And let's print out the area also. Alright, so we run this, and it says S is a 5 by 5 rectangle, area and perimeter are 25 and 20. So we can construct a square, we can use a two-string method, we can call the area and the perimeter method. But, you know, the glorious thing is, none of that was written by me inside this declaration of what a square is. All I did was write a constructor, and I basically punted to the machinery inside the rectangle class.
You can do this for, like, any class, right? Like linked lists and all that?
Yeah, unless it's declared final, I believe, which means you can't extend it. But effectively, any class you can extend it.
Or statics.
Or statics. So it's not exactly a call, it's really kind of saying take all the stuff inside rectangle, pretend that that's inside here. So it's kind of cloning or copying in some sense.
I guess you could use it as like a glorified typedef.
Kind of, yeah. But we can do more.
Yeah.
So when I did this, it said S is a 5 by 5 rectangle. Well, really, you know, S is a square. So what I'd like to do is when I call my two-string method right here, I don't want to use rectangles two-string. I'd like to use a different two-string method that tells me this is a square. So I'm going to put a method in here, public string two-string. And when I call toString, it's going to say a square with massive typos. A square with side equal to, and I'll just print out, well, I can't do length, but I can do height or width. They're the same, so it doesn't matter. So here what I'm doing is I'm overriding a method from the rectangle class. And so there's two things at play here. One, we inherit methods and fields from the superclass, right? So rectangle is called the superclass. We inherit things from that. And if I decide I want to call the area method for a square, and I haven't defined an area method, it calls the area method from the rectangle class. But I can also override things that were inherited. And so in this case, I've created my own public string toString. And so even though there's a toString method in the rectangle class, when I say let's call the squares toString, this is the method that's going to get called. So stuff that I write inside this class declaration take precedence over things that were inherited. And so this lets me add that one toString method. Now it tells me S is a square with side equal to 5. But the area and perimeter, I'm using the methods that I inherited from rectangle. So those are two concepts related to class extensions. We're defining this class. We're saying we extend this class, which is called the superclass. And the things that are inside a rectangle, we have access to those. We inherit those, but we can also override them with our own versions. And these take precedence. And this is what we're going to do in a few minutes with J-frames when we start doing graphics. Alright, so a couple of keywords that will pop up as we move through this. One is the keyword super. And remember, if we're inside this definition of the class name square, I've defined a method called toString. If somewhere inside here I call toString, this is what's going to get called. Right? I've overridden the toString method from the superclass. And if I just say toString, this is what gets called. But suppose for some reason I wanted to execute the toString method, not that I wrote here, but that I inherited originally from the superclass. I can get to that by using the keyword super. So I could say, you know, A is, or this thing is a square with side equal to, and I'll show width, which is also, and I can say super.toString. And this says, hey, let's run the toString method from the superclass rectangle. And so now this should say, you know, S is a square with side equal to 5, which is also a 5 by 5 rectangle. So even though you override a method that you inherited or a field that you inherited, you can still get to it by using this keyword super. And so super is, in some sense, it's an object, but it's the particular object. It's hard to come up with the language for it. It's the object as if it were a rectangle instead of a square, basically. We're not going to have to use this for a couple of weeks, and when we have to use it, it will be pretty clear why we're doing this. But that's one keyword we'll bump into. The other keyword is even harder to discuss because of the way English is, but this other keyword is called this. And this is basically a keyword for myself. it's a way to access the object that you're currently sort of running code inside of. And so let me give you a paper example. Suppose I have some class. I'll just call it stuff. Let's see. So there's stuff inside this class, right? Let's say there's a method. I'll just call it go. And there's some code inside here, but somewhere inside here, I use the keyword this. Okay, what does this mean? Suppose in my main program I say something like, you know, stuff x equals new stuff. And I say stuff y equals new stuff. And I say stuff haha equals new stuff. And I do some stuff. Okay, now suppose at some point I make the statement x.go. Alright, I'm asking the system to execute the code inside this go method. I'm saying x.go. So inside this go method, the keyword this refers to x. Right, so this means x. Now later on, suppose I say y.go. The same code gets executed, but when it gets to this line right here and it sees the keyword this, that refers to the object y. And then obviously if I say haha.go, and then I get down to a place where I'm using the keyword this now refers to haha. So this is a keyword we can use to figure out what we are, who we are, what our object is, right? And there's not really good language for this, or for this.
Curiosity.
Yeah.
Because I know C# does this a couple times, and I found it to be quite useful. But if you were to like be in a tree class and you're passing a node to this method, and you're using that to construct another node or something like that, like a new node, you can use this or that, right? So this referring to the new node that you're currently using, and that referring to the node passed to it. Is that correct?
I don't know if that is a keyword for Java.
Okay.
If it is, I'm not familiar with it. But you can use this to get a hold of yourself, and mostly that's going to come up like in PA 4 and 5. When we have multiple classes and we have something happening in our current object and we want to tell another class who we are so that it can get back to us and get to our fields and our methods. And so we might call an object and we might pass this as an argument, and call a method and pass this as an argument. And then that method will be able to save whatever the value of that argument is and then use it later to get back to us.
I don't see any keyword called that in C#.
No, I think it's other. I think you're referring to like a collider or something like that. It's saying if this object collides with the other object passed to this function. Yeah, that's what I put that in the text.
Alright, cool. Alright, so this also is something we don't need for PA3. It'll come up in PA4, I believe, and we'll talk about it then. There's another place that we can use the keyword this, though. And it's not strictly necessary, but it's probably the most common use of it. Oh, that didn't work. And that's when we're making these constructors. So you'll see this with constructors, you'll see it with accessors and mutators. We're making a constructor called rectangle. We want to pass a height and a width, and then we want to save that first argument in this variable called height and the second argument in this variable called width. And when I did this, right, I called the first argument h and the second argument w. Right? Now you don't really want variables with single letters. Some courses that's an automatic 0 on your code. So we'd like to call this something more meaningful than just h, and we'd like to call this something more meaningful than just w. And I could call it something like height argument and width argument. Then I could say height equals height argument and width equals width argument. And that's not horrible, but it's not really what I want. What I really want to do is, I want to call this argument height, and I want to call this argument width, because, dang it, it's the height and the width of the rectangle. And the only problem with that is these assignment statements now become meaningless, because this statement says height equals height, and this says width equals width. And those are no-ops. Why? Because height is now a local variable declared inside this method. And anytime I use the word height inside these angle brackets, it refers to this argument. So this is just setting the height equal to itself. What I really want to do is I want to take this height up here and set it equal to the argument height. And I want to take this width up here and set it equal to the argument width. So what I'd like to do is, not just use the word height, H-E-I-G-H-T, which means local variable argument that we passed. But I'd like to say, inside the current object, let's get the field named height. Well, the current object I can access with the keyword this. So if I say this dot height, it means this thing up here. And so this dot height equals height means take the argument that I pass to the constructor and set this variable that's defined as part of the class equal to it. And then down here, I'll say this dot width equals width. And so you'll see this kind of construct done a lot. It's not something that we need, because we could call this, height underscore, width underscore, or something like that. But it's probably the most common place where you'll see the keyword this being used.
And so this would be basically like something saying my height variable and what's being passed is the same name, basically.
Mm-hmm.
So I'm referring to this being the local variable and height being the what's been passed to the method,
Mm-hmm.
the constructor. Okay.
Yeah.
That makes sense.
Cool.
It's also like one of those job questions. What are the implicit parameters you're supposed to say self and this, or self or this, and super and base?
Oh, okay.
Which is like, do you think about 222, where we were like passing a struct into these functions? That's like passing this into all those functions.
Okay, right.
It's like passing the self of the state of the class into the functions. So
That's cool. All right. Any questions about that? Like I say, it's not something to get terribly worked up over right now, because we'll use these in ways that are more meaningful down the road, particularly PAs 4 and 5.
If you didn't put this and you have your local variable the same name as the parameter, is it gonna throw an issue, or will it pretty much figure it out?
Nope, it'll just set width equal to itself, which has no effect on anything.
Okay, so it's not like something that you can just leave out. You have to either change one of the names or put this in.
Mm-hmm.
Okay.
Yeah, otherwise I don't believe it's a compile error. So I think it compiles and it runs just fine, but it, copies this argument's value into itself, which is basically a no-op. And it can drive you nuts trying to figure out why You know, it's not remembering the dimensions of your rectangle.
I guess that makes sense.
All right, so those are on the server for whatever they're worth. All right, good to go. Python and Unity, good stuff. Yeah, self would be a little easier to talk about.
It's like in that language you have to use it, so you can't just put like member variables in the class scope and just use them in all the methods.
You have to actually say self?
Yeah, you actually have to pass in self on every method.
Okay, that may be even worse than mandatory indenting. I kind of like the indenting though, because I think it encourages, you know, good habits, but probably it doesn't actually.
I don't think it's a really great language to learn object-oriented with.
Yeah, but it's on my list to learn because I've got some research uses for it.
I
But
use it at work for databases and stuff.
yeah, very popular language for sure, and very popular with non-computer science types, people who just want to do things with computers without, you know, falling in love with them. Python really kind of won that crowd over a number of years ago. So I will probably be digging into it this summer.
Yeah, from what I got from, I think it was 120, the first programming class.
Mm-hmm.
It was pretty easy to learn and do a lot of really complex things in very little bit of coding.
Yeah, yeah. My problem is when I want to do something slightly different, then I have to like dig into all this weird documentation, and it's never the slam dunk I'm looking for at the moment. So I need to really kind of step back and like learn it at a deeper level instead of just get by with it.
Yeah, the cool thing with Java is there's so much documentation, it's so easy to like find things.
Mm-hmm.
I haven't really looked into Python, but
I have about a dozen really good Python references bookmarked, which is kind of one of the problems. All right, let's move on to Swing then. So let's start playing with Eclipse and doing some graphic stuff. And so let's begin with one sort of final non-Eclipse version. Let's make a graphic thing happen from the plain old, you know, editing with VI, compiling with Java C. And then we'll move into using Eclipse and Window Builder. Alright, so I'm going to have my main class, and I'm going to do the following. I'm going to create something called a J-frame. Well, what is a J-frame? J-frame it's a class. We're doing Swing. I can open my camera now. J-frame is a class. It's an extension of a frame from AWT. AWT is the abstract windowing toolkit. It's sort of the low-level graphics version of making widgets and stuff. A frame is an extension of a window, which is a container, which is a component, which of course is an object. These are extensions, right? So the declaration for a component, it extends an object. A container extends a component, and so on. And so a J-frame is an extension of all of these things. It's a hierarchy. And if you look at the methods, these are the methods that are available inside a J-frame. But because a J-frame is also an extension of a frame, all of these methods that are defined inside the frame class are also available in the JFrame class. And since a frame extends a window, all of these methods from the window class are available in the frame class, which means they're available in the JFrame class. So if we have a JFrame, we can call, for example, set size. We can call set visible. We can call to front or to back. And so there's all of this stuff that you can call associated with a JFrame, but most of it is not part of a JFrame itself. Most of these methods belong to other classes, and a JFrame just said, yeah, I'm going to extend this other thing called a frame, so give me access to everything that's in a frame. Right? So thinking code reuse, thinking, you know, if there's already something called a container that does a lot of stuff, why do I want to rewrite all of that code? Well, what we're going to do is we're going to create extensions of JFrames and JPanels and other Swing classes, which means, you know, as soon as we define a class that extends a JFrame, our class contains all of these methods and all of these methods. And so if we want to be able to change the dimensions of our class, we don't need to write something that, you know, takes a pair of integers and adjusts the size. We can just call the set size method, and as long as we haven't written our own method called set size that takes 2 integers, it will call set size from the window class. So let's do this. Let's make a JFrame, and what should we call our JFrame? I'll call it J.
I have a quick question.
Yeah.
Based on that comment you just made. So, say we did make our own set size, but we only took one parameter, and we passed it 2. Would it call the default set size there that's already passed?
Correct.
Like, is it like the okay? So it's kind of like the constructor in that way. If you want to pass nothing or one thing or two things, you write that as different constructors, kind of the same thing.
Yeah, so it's the notion of signatures. So something called set size that takes 1 integer is a completely different method from set size that takes 2 integers. It's just like if I called it, you know, toodaloodle instead of set size. It's a totally different method.
Oh, okay, that's cool.
Yeah. Alright, so I'm going to call JFrame J equals new JFrame. If I try to compile that, it will tell me it does not know what a JFrame is. Right, so cannot find the symbol. So what did I forget to do in my code over here? Didn't import. Right, so string, boolean, these are available by default. Linked list is not available by default. We have to import it. Same with scanner. Same with all of these Swing components. So first thing I'm going to do is say import. And I'm going to import javax.swing.jframe.
If you import JFrame, that basically imports everything before it too, right? That inherits from?
Effectively, yeah. I don't know if it actually imports. So that's a good question. I don't think it actually imports, say, Java AWT window. I don't know how the extension mechanism works under the hood, but that would be an interesting test. Just try to call a method. Try to construct a window. Well, let's just try that. Yeah, so it doesn't actually import those things that you're extending.
Okay, so it kind of like imports the methods that it inherits, but it doesn't allow you to actually construct a container or window.
Yeah, I mean it's really, yeah, I don't know how it's implemented, but the effect is that, you know, everything in a JFrame includes everything in a frame, a window, container, and so on and so forth. But I don't think it actually, you know, does something that kind of crude. I think there's something more nuanced going on. But the effect is that, you know, everything that's in a frame is accessible inside a JFrame. But I don't think it just, you know, calls a frame object.
It's probably doing that to avoid like cyclical imports, right?
I don't know. But hey, you know, we have the source code. We could go figure it out. Then we could change it if we didn't like it.
Yep.
Alright, so this should compile. And if I run it, you know, nothing happens. Comes back. Well, that's fine. I constructed a J-frame, so what? Right? If I had said string s equals new string, it would make a string and then it exits. Right? So we want something to happen here. So there's a method called setVisible. So let me call this lowercase j because it's an object. So I'm going to say j.setVisible true. Now when I compile and run this, something very different happens. Right? It does not exit. I lost focus, right? My cursor turned into empty and my bar got grayed out. And I don't believe I can grab this because, well, let me do this. So over here on my other monitor, I have this little tiny thing sitting there. And that is my J-frame. If I grab a corner, I can expand it, and there it is. So the default size is really, really small. And the default position happened to be the upper left corner of my second monitor. And it's not a very interesting frame, but it kind of is. You know, it's got the blue title bar up here. It's got ways to maximize. I can double click to demaximize. It's got the little red-nosed penguin type icon here for Java. And if I hit the X button, it will close the window, but my program continues running. So there's definitely stuff going on here. All right, so let's expand this code a little bit. Let's make my window 300 by 500. And let's set the position of it to be 0, 0. So 0, 0 will be the upper left corner of this monitor over here. So this should show up here, and it should be 300 by 500. So we can compile that, except I called it J, so it's not set position. Looking for something up here for setting the location. Set location.
Set location, yeah.
All right. And again, you know, signatures, so I can call set location with an XY pair to fix the top left corner, or I could call it with something called a point. And a point is a different type of class that basically is just like a C structure. It has two fields, X and Y, and you can construct with, you know, nothing or with X and Y, and it's got a few methods. So let's name this thing correctly. Let's set location. Let's compile that. And then let's run that, and bingo, there's our window. 300 wide, 500 high. And again, we can change the size of it and so on and so forth. Alright, if we look at a J-frame, and we look at the constructors for it, we can construct with no arguments. That's what we just did, and it says the frame is initially invisible. We can also construct with a title. We can give it a string, and it will create a new initially invisible frame with a specified title. So this will be our final tweak on this. Let's construct a new J-frame, and we'll just give it some weird title. And compile this and run it. And hey, there's our frame. And it's got our little title bar up there. Alright, so this is kind of a hello world for Swing, right? Although not a very exciting one. And we could have called the title Hello World. But it leaves a lot to be desired, including the fact that, when I close this frame with that X bar, my program is continuing to run. It's not doing a whole lot, but until I Control C it, it doesn't actually exit. But here's a few things we can do. We can construct a frame, make it visible, set its dimension, set its location. I just won't sleep well if I don't actually make a hello world. There we go. Alright, so we can do all of our graphics development, we can do all of our GUI development and our other programming assignments just like this. We can, construct objects, we can set properties on them, and it's kind of a lot of work. And if this was a class on learning the ins and outs of the swing package, that would be an appropriate thing to do. But really what we want in the second half of this course is to use all of these classes that are available for us to do other things. And we want to get practice with, extending what we've done in PA3 and PA2, which is taking these classes and creating objects and then using them as, self-contained entities with data and methods and putting them together. And, if we want a linked list of J-frames, we can make a linked list construct with angle bracket J-frame, and bingo, we got a linked list of these little windows, on our screen. That's totally a thing to do. So we're going to switch gears and use Eclipse, and we're going to use Window Builder inside Eclipse to work with swing classes more efficiently. So we're going to use Window Builder, which is this drag and drop interface, for setting up all of this kind of code that we're going to have to make. So I'm going to put this code over on the server just for reference. But we're not going to do this for the most part. We're going to switch to Eclipse. So hopefully people have gotten Eclipse up and running and have got Swing and Window Builder installed. We're going to do about a 5-minute break. And so if you want to get that fired up and play along as we go through this, you can do that. Or you can take notes or just watch and come back to the video and so on. But I want to start working with some of these elements inside Eclipse and dig more into what they can do, and then we'll talk about kind of higher level concepts related to working with these windowed classes. So let's take a break and let's come back in 5 minutes. All right, so I'll see you back in a few. Alright, welcome back. Let's see, someone said, I noticed when you try to install Window Builder and Swing on Windows, you may need to update the Window Builder and Swing packages in Eclipse if the design window is broken. So Window Builder can be tricky sometimes. And this year it seems like it's working pretty well, at least under Linux, with the particular versions that we downloaded the other day. But it's always a little bit adventurous. One thing I will tell you is sometimes what we're doing will start to break, and it will say, you know, do you want to try again? And seriously, if you try again, like, 10 times, the 10th time will suddenly work. That was a particularly bad year. Haven't seen that happening this time around, but we'll be aware of it.
I had lots of issues getting Eclipse going. Like, I tried to follow you along last Thursday in installing it, and I just kept getting hangs again and again and again. And then this morning, I tried to get Swing and Window Builder up and going.
Mm-hmm.
And, like, initially the design window was just bork every time, so I had to go in and manually update the packages in order to get the design window to not be broken. So
How did you update the packages?
So I went into if you go to the help window, it'll say Eclipse Marketplace right there. And then I went and I looked for Window Builder, and it'll say installed. And I just clicked on it again, and it went through an update, and it redid it. It was a little bit fidgety.
Interesting.
But I got it working.
But you originally did it from install new software?
Yeah.
Okay. Yeah, that's doesn't sound like a feature, but
It's always a feature.
yeah, right. All right, so let's play around with this. So when you open this up, you will get something that looks like this. And there's nothing over here. So let me just go ahead and delete this. And when you first open Eclipse, it'll ask you what workspace you want to use. That's sort of the starting, the root of a tree of directories where your projects will sit. So, pick somewhere on your machine that is dedicated to this, and that's going to be backed up frequently and reliably and so on, and make that your workspace. And you'll get something like this. And so I usually close this window over here, but you can move things around in here. You can pick these windows up and place them in different places, and customize the look and feel of this, just like MPLab or any other reasonable IDE. I don't really have a whole lot of experience with doing this. I kind of take the default perspective and just run with that. But if things get wonky, you can always go to Window, Perspective, and Open Perspective, or Reset Perspective. Get back to here. So I'll close this. This is basically where your code is going to appear. This is going to list all the projects in your workspace, and this is going to be like your console input and output area and error messages and stuff like that. So pretty straightforward. So let's create a JFrame, but let's do it using Eclipse. So we'll start off with File, New, and I'll say New Java Project. And
Is there any way to just have like a very basic solution explorer instead of all the packages you have?
so you can organize things. Well, it's been a while since I did this. You can organize things using some of these options in here. I'm in the middle of this, but I think if you go on this one, you'll see some options for it. But it's not really great. And really kind of the ideal, I think, is to have a separate workspace for each project. But when you switch perspectives or you switch workspaces, it resets all of your preferences. So if you customize this, which you'll probably want to do, that kind of short circuits that that feature. So usually I live with, you know, one workspace with several projects in it, and when I get tired of it, I'll go to another one. So let's create a project now. I'm just going to call it Amazing Stuff. And the one non-default option you want to do the first time you do this, uncheck this box. This will be checked by default. Uncheck it, and then it should stay away from that point on. And I'm just going to say finish. The other thing is this reset to 17 on me. So I did this yesterday. Alright, I'm going to do this from scratch again, because I tried to use this pre-installed setup that I had yesterday, and I ended up spending a lot of time. So I'm just going to install this from scratch, and this will be another opportunity to see a run-through of how we install this, starting with having downloaded the Eclipse installer, right? So I won't do this step again, but you know, Eclipse download, look for eclipse.org, Eclipse installer 2022-03. So download that, and you'll get a tar.gz file. Unzip it, tar xvf it, and it will leave you a directory tree that looks like this. So I'm going to run the installer from here. And this is a relatively quick process, at least compared to geological processes.
Geological process.
So we want Eclipse IDE for Java developers. So I'm going to double click that. And here's the critical thing. You want Java 11, right? Don't go with 17, which is the latest one. Make sure you do Java 11 and then whatever installation folder you want. I'm just going to call it this, and this time I'm going to make a note of that folder so I don't have to do this again. Alright, I'm going to say install. And it's a pretty quick install. Pretty quick. Alright, go ahead and launch it. Alright, default workspace, I'll just go with the default. And I'll say use this as the default and don't ask again. So that's the root of the directory tree for all of my work. And yeah, I'm not gonna do that.
Hey, quick side note.
Yeah.
For ODP 306, can we assume that you're not going to put in 0 when you divide?
Yeah, that's a good assumption.
Okay.
Alright, I'm gonna go to a different workspace. I was playing around with dark mode yesterday, so I want to give you like a full out-of-the-box experience here. Okay, so here's our default setup, and this should work fine for just doing kind of a generic Java project. So I'll just call this project 1, but I'll call it project 12, and let's just make a new class, and I'll say let's create a public static void main, and then we'll just add a print statement. And then we'll run it with a little green triangle button, and we'll say always save before you run, and then down here in the console we see the output message hello. So this works fine for just doing, you know, Java code like we've been doing so far up to this point. So let me close this project. Same advice I do in MP Lab, same advice I do for all of these IDEs. Only have one project open at a time, right? It will ultimately save you a lot of frustration. Make sure you only have one project open at once. Alright, so we want to play with Swing. We have to install it. So go under Help, Install New Software, and select a site. Go with that first one, 2022-03. Search for Swing in here. I'm going to check that box to check all the other boxes. Click through twice. There's one, there's two. Accept the license terms and say Finish. It'll reboot. Let that go. Alright, so now we're going to install Window Builder, so same deal, go to Help, Install New Software, choose a site, 2022-03, type filter text, Window Builder, gonna check that first box to get all of those, click through 2 times, accept the license terms, and then Finish. It'll restart once more. I'm going to close this. Alright, so we should be all set. So let's close this out. Here's our package explorer. So yeah, working sets are the way that you can group stuff. I can take a bunch of projects and group them into different working sets, and then this will be indexed by working sets, and it's kind of like a bit of a directory structure. But like I say, it's not really all that great. So let's make a new Java project, and we'll call this Great Frames. And I forgot to uncheck this last time, so I'm going to uncheck that box. So we got a project named Great Frames. Alright, and it's open because it's got the little triangle next to it. This is closed. You can have more than one project open at a time. Don't do it. Right? Easiest way, click on the project that you want open, right click and say close unrelated projects, and it will close all of these. And Eclipse is pretty good. It'll be chatty with you, but it gives you an option to say, would you like me to be less chatty in the future? And you can say yes. So it'll pipe down over time. Alright, so we're going to create a JFrame. So we're going to right click, we're going to say new, but instead of saying class, we're going to say other. And we're going to scroll down here to Window Builder, expand that, scroll down to Swing Designer, expand that, go down to JFrame, say next. I'm just going to call this main, and we'll just say finish. And bingo, we got a bunch of code. And some of this code looks like code that we wrote before. Here's where we make the frame visible by calling setVisible and passing it true. There's a bounds method, which is a combination of a position 100 100 and dimensions 450 by 300. And there's some other stuff going on in here, but there's the keyword extends. So we said let's call the main class main, and this is a declaration of public class main, and it's saying main extends a JFrame. So when we construct a main, and I'm calling it frame, right? This is an object of type main. It's the class that we're defining right here. But frame has a setVisible method, right? Why? Because there's a setVisible method in this class. But we haven't written a setVisible method in here. We inherited setVisible from JFrame, the class that we're extending. So that's why we can say, let's take this object of type main and set visible to be true. Alright, the constructor for main does a few other things. It calls this method called setDefaultClose operation. and it passes it a value which is a static field from the class JFrame, and it's called exit on close. And what does that do? Well, that says when you close the window, the program should exit. So there's a field. There's a field defined. It's a static integer exit on close. That's part of JFrame. What's its value? I have no idea. Could be 1, could be 175. But we don't care about the integer value of this. What we care is that when we close the window, something inside the class will look to see what the value of some field is. And if it's equal to whatever this value exit on close is, it will, presumably exit our application. So when we call the set default close operation, we pass it that value without ever knowing what it is. Right? So it's kind of like a constant. All right, there's some other stuff that happens in here. This code creates what's called a JPanel, and it sets a border, and it sets something called a layout, and it adds it to this JFrame and a bunch of other stuff that we don't know. We don't necessarily care what they do, but let's go ahead and run this. Right? We run it, and there's our frame. And it's resizable, and we can move it around and so on and so forth. And we can see that it's running because our little play button here is red. And if I hit that button, that will close the program, right? So it says it's terminated. But also, if I have this JFrame and I hit the X button, that'll terminate the whole program. Why? Because we said exit on close. Now, if we didn't do that, then we've got similar behavior to what we had before. We've got a JFrame, but when we close the frame, the program continues to run. And I have to actually force it to stop by hitting this terminate button. All right, so here's one way we can get in and we can start manipulating these swing elements. But the more powerful way is to use window builders. So there's a tab down here that says design, and if we click on that, we'll get this other layout. And hey, there's a picture of our JFrame. And this design window is linked to the source code. So for example, the source code says, let's set the bounds to 100, 100, 450, 300. If this code actually says 450, 450, and then I look in my design window, I see my JFrame is a square now. Usually when we make changes to the design of these graphical elements, we're going to do it in this window. So we might take this window and we might shrink it by grabbing a side and reducing it. And that in turn will change the code. So now it's saying that this is 450 by 238. So these two windows are linked. The trick is, it's really easy by typing things into the code to break this. And so everything related to, the layout of our frame, the dimensions, the colors, things like that, we really want to try to do through this part of Eclipse, this thing called Window Builder. And then the sort of machinery underneath the code that's going to, do the things that we're actually writing, that we're going to write, in Java. And it will interact with the stuff that's in here. But when you can do something through this interface, let's do it through this interface. And there's less chance of getting into trouble. All right, so what have we got here? I should tag this, right? So I'll just call this Window Builder Demo, etc. Default close operation, right? So we're looking at the JFrame, right? There's also a content pane. So if you go back to the code, we noticed that it constructed something called a JPanel, called content pane. And then it said set content pane, content pane. Well, basically, you know, this outer box here, this is a J-frame. That's the thing we've been working with. But there's also this thing named content pane sitting inside here. What is a content pane? It's something from Java X Swing JPanel. So let's look at the J-frame. So default close operation. Well, right now it says exit on close. If I click over here, I can choose a different default close operation. For example, I could say do nothing on close. And now in my source code, it says set default close operation jframe.do nothing on close. So let's stick with exit on close because that's a nice one. And we can set a title. So I'll set a title to say this is a great frame. And hey, there's a title right there. This is a great frame. And how does that happen? Well, because this code now calls the set title method. Set title, this is a great frame. Well, I misspelled it. And if I run this, right, I've got my window, but it's got this title on top. So one thing you can do is you can spend, you know, billions of hours playing around with these different properties and seeing what they do, right? We can make something always be on top. We can play around with the background color. We can disable it. We can play around with the font, the foreground color, the icon that you get when you iconify it, and so on and so forth. And these are the most common properties. If you click this button right here, it will show you advanced properties, and there's a lot more you can do to sort of control the look and feel of a J-frame. All right, and then a content pane, that's this panel inside here, and I think we can probably play with like the background color. Let's pick a really pukey color like that, and bam, you know, so we'll burn our retinas there. So we've got this, you know, horrifying turquoise window now. And how did that happen? Because the content pane is now being used to run a method called setBackground, and it's passing it something called color.cyan. Well, cyan is a field. It's a static field in the color class, and it corresponds to, you know, the information that goes along with that color. So we'll go back to something less disturbing. All right, and you know, you can play with the border. You can pick a bevel border and make it look raised, and you can, you know, kind of spend your life playing around with all these different options and so on. But you know, it subtly changes the appearance of the frame. And so that's one thing you can do, right? So this kind of looks like it's popping out now. So those are properties, right? They're basically like variables with particular values. The other thing you can do is you can, for example, if I right-click on this J panel, I can say add event handler. And there's all these different categories of event handlers. All right, so let's talk for a minute about event-driven code. So usually when we write code, we say, you know, do this, set I equal to 0, set I equal to I plus 1, see if I is bigger than 10, print this thing, go back here and do this again. If this thing is true, jump over here and start doing these things. Now call this function, execute these steps, come back, now go back to the top of my loop. We define a series of statements to be executed one after another. And the code we write in 224, the code we write in 222, or that we've written so far in this course, is very sort of procedural in nature. where we're describing, you know, a sequence of things to do. And we're going to stop doing that with PA4 and PA5, and we're going to switch to a different mindset of writing code. And this is going to be the mindset of event-driven code. And so if you've already done Engineering 270, you've written event-driven code when you dealt with interrupts. You had a lab where you had 3 LEDs and they were blinking in order. And then when an interrupt occurred, it should stop that sequence and turn on 1 LED for 2 seconds or something like that, and then go back to that sequence. And a lot of our interrupt-driven code, the main program basically just said, you know, loop, branch to loop. It just sat there and spun in an infinite loop. But before we did that, we set things up so that when an event occurred, for example, when pin 18 got raised to 5 volts, or a timer expired, the code would stop what it was doing and it would jump to some other location, 8 or 18, execute some code there, and then go back to where it was. And that's what most of the code we write from here on out is going to look like. And when you write code for game development, for Android Studio, things like that, it's usually event-driven. You're not sitting there polling, you know, continually saying, did you touch the screen? Did you touch the screen? How about now? Are you going to touch the screen soon? Have you touched the screen yet? Right? That would be a really inefficient way. What we do is we say, hey, if someone touches the screen, let me know. And then, you know, your phone goes off and it just kind of hangs out in a loop somewhere. And then when you touch the screen, suddenly the code jumps to some other location, which means, hey, somebody touched the screen. Or, hey, the phone call is coming in. Or, hey, we just changed GPS location. Right? So our code responds to events. And that's what we're going to do inside Swing. And that's how we're going to write PA4 and PA5. It's mostly going to be event-driven. And if you look at our main program, so far, here's our main program. Forget about the runnable stuff. That's something else we'll have to talk about. But our main program, you know, it's got one method named run, which creates a frame, makes it visible. If there's no exception happening, it just exits. Our main program returns almost right away. So it's not sitting there looping saying, hey, did you grab a corner and drag? Should I resize the window? But things are set up so that when that event occurs, code will execute. So we can add some code to respond to different events as we like. So for example, if I right click in here and I say add event handler and I say mouse clicked. Well, some code appears and I find myself at the beginning of a method called mouse clicked parentheses mouse event. And let's just put a print message in here. We'll just print out the word click. And so now if I run this, I've got my window sitting over here. If I move my mouse, nothing happens, but you'll have to trust that I'm going to click the mouse now. If I click the mouse, it says click. And if I right click, it says click. And if I click with my scroll wheel, it says click. Right? So there's nothing in here that's saying, you know, check the mouse button. If it's equal to, you know, pressed, then go ahead and print click. We create what's called a mouse listener. This is the thing that basically tells the system, hey, if you see a mouse click, let me know. You know, other things on the system will want to know about that also. But somewhere along the way, when the mouse gets clicked inside this panel, let me know. How do you let me know? Run this piece of code called mouse clicked. And mouse clicked is a method that's called and it's passed an argument of type mouse event. So what is a mouse event? Well, it's another class. Comes from the Abstract Windowing Toolkit. And mouse event has, among other things, a method called getX and a method called getY. And these return the horizontal and vertical positions where the mouse click occurred. So we could change this code and do the following. So our mouse event is called E. And so I can print out, you know, we got to click x equals e.getx and y equals e.getY. And so if I run this and I click my mouse, it tells me the XY positions where that click occurred. So up here in the upper left, this is close to 0, 0. And as we move to the right, X increases. And then as we move down, Y increases. And so the lower right is the largest X and Y coordinates. So interesting thing to note here.
It's different in every program.
Yeah, and it's different from algebra class, right? Normally X goes to the right and Y increases moving up. Almost every graphics system, well, every graphics system I've encountered, X runs from the top to the bottom. So 0, 0 is sitting up here, and then the largest value is down in the lower right. Any idea why that is? You can blame that on television.
Yeah, because CRT monitors, the cathode ray would like start from the top left. Go down.
Mm-hmm. Exactly. So on television sets, if this is the front of the screen like you're watching TV, the way that the image is drawn always begins in the upper left. It sweeps horizontally. And then when it gets to the end, it does a horizontal sync, comes back and sweeps the next line down. And then comes back and sweeps the next line down. And so the first place that it draws is up here, and the last place it draws is down here. And then it does the flyback and comes back up to the upper left. And early graphic systems, you know, were built using CRTs and using the same kind of system. And so it makes sense to begin your XY coordinates up here where the raster beam begins. And it seems like we're stuck with that forevermore. But that's okay. Which way does Z go, by the way? Does it go into the page or out of the page?
I've seen multiple things where Z is where you think Y is, and Y is where you think Z is, and then in some other, like Blender, Unity, and Unreal, and Godot, they all have different implementations.
Yeah.
Of Z is.
So if I did X like this and Y like this, where would Z go?
I think they would go out of the page most of the time.
Z would go straight at you.
Actually, it would go into the page. So it's right-hand rule. So come out on X, turn your fingers toward Y, thumb tells you the direction of Z. That was your physics pop quiz.
Yeah.
But that's if you're right-handed. If you do a left-handed system, then it would come out of the page. But most of these systems are right-handed, so once in a while that might save your life to know that. Or, you know, get you bragging rights at work. Alright, so X goes across, Y runs down, and we can explore that by clicking around here. Now if I click up here on the title bar, nothing happens. I can maximize, but my click code does not fire. Right? Why is that? Because over here, that event handler that I put was part of this content pane, this thing which is a JPanel. The title bar is part of a JFrame. Now the JFrame itself, I could also add an event handler. But we're just playing with a JPanel for now. Alright, what other kinds of handlers can I have? So, when you get focus, when you lose focus, right? So all of our systems have a notion of focus. Where would your typing go if you started to type? Would it go in this window? Would it go in that window? So there's always one window that's the most forward. That's the one with focus. We can respond to key presses. And let's just take a look inside this code. Let's just print out this argument E that's passed to the mouse clicked method. And E has a really big toString method, right? So it's got this stuff in the beginning that says mouse event. It's telling you that a mouse was clicked. It's telling you the XY positions. It's telling you absolute XY positions. Well, what are these? If I click down here, it's telling me I clicked at 3914. That's inside this J panel, but it's also telling me on my laptop screen, where did I click? 1431 and 531. So that's kind of useful. And presumably all of this information I get by just calling the toString method on mouse event has been exposed in some way through various methods in that class. For example, get X on screen, get Y on screen. That gives me the absolute position. Button equals 1. That tells me that I'm left clicking. If I right click, it says button equals 3 right here. If I middle click, it tells me button equals 2. If I left click while holding control, it tells me modifiers equal control. If I left click while holding control alt, it tells me modifiers equals alt plus control. So there's lots of information available in here. And whatever information you need, you can use. Whatever you don't need, you don't care. But this is another example of the idea that, you know, everything is an object. And so when we call this method, we pass not just the XY positions of the click, we pass an object called a mouse event. And it has, you know, all of this information inside it, and it has all these methods inside it that we can call to work with that information. Alright, so let's try something else. Let's add a event handler for mouse motion, and let's say mouse moved. And here I'm just going to say system.out.println parentheses plus e.getx plus comma plus e.getY plus parentheses. And so now, just by moving my mouse around here, I'm seeing XY coordinates. And every time the mouse moves, this code gets called, this method gets executed, and it prints out these coordinates. And if I'm outside the panel, nothing happens. If I'm moving on the top bar or over these, nothing happens because I'm not inside the J panel. But as soon as I get inside the J panel, this middle area, any mouse motion causes this method to be executed, and in this case, you know, I'm printing out XY coordinates. Now, if instead I decided to draw a little colored dot at that current XY location, I'd have a drawing program. We'll wire up something like that on Thursday. So this is pretty powerful stuff, right? We can connect code with different kinds of events. And just looking at the J panel, right, we've got this whole collection of events that we can choose from. But we can also take different components like J buttons, J text fields, J labels, and place them in this panel, and then interact with those. So what's a J button? So it's another class, comes from Swing. And we can construct... Go ahead.
Are we going to talk about bitmaps at all?
Bitmaps. We might. We're definitely going to talk about drawing and using the paint method and drawing with individual pixels or lines on a graphics object. And we can probably talk about bitmaps a bit. They don't take too much beyond that. So yeah, remind me if we don't get to those.
Cool. I have a project I want to do.
Yeah, they're pretty useful when you need them.
Yeah.
So we can construct a J button just by saying new J button. And what is a J button? Well, it's an implementation of a push button. I'm intrigued that push is inside quotation marks. I'm not sure that's proper. Yeah. I don't know if depressing is the same as pushing. All right. So we can grab any of these elements, and if we left click and release, we can bring it into here and drop it wherever we want. But by default, when I do this, I've only got like 5 places I can drop this object. North, south, west, east, and center. You're flashing back to traffic lights in 250, aren't you? And maybe I want to put my label like right here. So by default, there's what's called a window manager. So window managers, they're kind of a love-hate thing. Here's the idea: you've got a cell phone, right? And you're running a browser on it, right? And your browser looks a certain way, and there's a search bar, and there's a back button, and so on and so forth. And somebody else is running that same application, but on a different sized phone, something with a much smaller display. And somebody else is running it on a tablet, and somebody else is running it on a phone that's rotated 90 degrees, so it's in landscape mode. And so if you simply created a browser window by saying, well, here's how big the browser window is going to be, and here's the search bar, and here's the back button, right? And then somebody ran this in landscape mode, well, there'd be the search bar there, and there'd be the back button, and you'd have all the space over here, and so on. So usually when you're creating graphical interfaces, you want the display to be adaptable. You don't want to just specify this is going to be at location 10, 20. You want to say something like anchor this far from the upper left corner, and then put this bar this many spaces to the right of that icon, and then put a button centered halfway between the end of this and the end of the display, so we'll have some button right here. And so you usually like to have your layout managed by some sort of software that can adapt to changes in the display geometries. But I don't want to do that, right? I like deciding where things are going to go. Oh yes, originated CSS. So everything that I do in here, I'm going to begin with the following step. If you want to work with a layout manager, go for it, right? They're pretty useful, but for the sake of learning how to use these things, I don't want the added complexity of having components moving around and so on. So I'm going to left click where it says absolute layout, or absolute. I'm just going to left click and release. I'm going to come in here. I'm going to get this green box around my panel. I'm just going to left click. And if I look at my source code, what I've just done is I've added an absolute layout manager to my J panel, and somewhere in here I can't find it. It's in there somewhere. Set layout manager null. Alright, so that's telling me wherever I put a component, that's where the component's going to be. So now I can take a J label, left click and release, come in here, I can drop it wherever I want. There it is right there, and I can type, haha. And there's my label called haha. I can take a J button and drop it right here, and there's a button, and I'm going to change the label to go, and I'll take another J button and put it right here, and I'll change the label to stop. Alright, so what have I done? I've written a bunch of code, right? I created a J label called label haha, constructed it with an argument of haha. I've set the location and the bounds, And then I've added it to the content pane. That's what makes it appear in my J panel, right in that middle area. Created a button called Go. I created a button called Stop. And, you know, if I run this, now I've got this window with, you know, buttons and a label and so on. And it's still, you know, showing me my XY coordinates as I move around. But when I move on my button, I'm not getting that code executed in the J frame. The button is capturing that mouse motion event, right? Same thing with, maybe with the label, maybe not. The label's not capturing it, but the buttons are. And this is an absolute layout, so if I make my window look like this, that's what it looks like, right? So if you use a layout manager, it might decide, you know, okay, well, let's put the go button here, let's put the stop button down here, let's move them to the left, let's put the label there. We're just doing absolute layout. So what you get is what you saw.
Can we make that assumption for PA4 and 5?
PA4 and 5 you get to choose yourself, but you're welcome to just say this only works with this size window and not worry about, you know, window resizing.
And you can also lock the window size if I'm not mistaken.
You can also disable resizing so that you can't actually change the size of the window. All right, so let's tie some code to these buttons. So if I double click on this button, it will take me into an event handler. So this is add action listener, new action listener, action performed, etc., etc. Okay, I don't care what any of that is. I'm just going to put a print message here. System.out.println. And which button was this? I'll just say go button clicked. So I can run this. If I click the go button, it says go button clicked. If I click the stop button, nothing happens. All right, I'm going to get rid of these printouts here because they're distracting me. So now we've got something with a go button that prints out a message, a stop button that does nothing. Well, we can do whatever we want in here, right? We're using print messages to see what happened, but we could do other things. So for example, this label is called label haha. Well, let's change the name of that. Let's call that my text. So now if I look at the source window, it's JLabel my text equals new JLabel. Well, what is a JLabel? It's a swing component. It's a class. And it's mostly for displaying a little bit of text. It's not really something you would use to click on or things like that, but it's a way to display some information. And you can construct it with an argument, which is a string. You can construct it with no argument. But it's got a few methods. And one of the methods it has available is setText. And setText basically describes what's going to be displayed on the label. So I can come into my code and I can do something like this. So I have a JLabel called my text. And over here, when you click the go button, I say go button clicked. But let's do this. Let's say my text.setText. And we'll set the text to ha ha ha. Alright, so we've got our go button over here. We've got a label that says ha ha. When I click the go button, watch what happens to the text. Right? It changes. Alright, not very exciting by itself, but this really is kind of like, you know, the use case that makes everything else possible. So I can do something like this. Let's see. I'll make an integer called count, which is equal to 0. So I'll call setTextCount, and I'll add a string to it to, you know, call the toString method on count. And before I do that, I'll increment count. Didn't like that. Oh, I'm doing something bad here. Hold on. This is... So eventually we're going to talk about something called an inner class, which is what's going on right here. Because what's happening here is I'm calling a method called addActionListener, and the argument to that method is actually a new action listener declaration. It's a bunch of code. And so I'm creating this method inside the... I'm creating this class inside the argument list to a method. And it doesn't want me to do this. So let me see if there's a quick way to fix this.
Are there, is there any way to do like an inline function in Java instead of just like a full public void?
That's kind of what's going on here. It's actually like an inline class, which also includes a method, in this case called actionPerformed. But I'm planning to talk about that separately another day. It's another one of these things that's not strictly necessary, but it's a useful convenience, and particularly with something that's writing code for you, you'll see it happen all the time, which is where we're calling this method addActionListener, but the argument is all of this stuff, right? Which is actually constructing a class and overriding one method in that class. So that's called an inner class. So let's when we click the go button, let's change the text on the label to count plus you know, nothing, and then let's increment count. And I just changed count to be basically a global, just a variable inside the J-frame. So if I run this, our label's haha. Every time I click the go button, it basically counts how many clicks I've had. And, you know, the obvious next step, let's take the stop button and let's change the count equal to 0. And let's change the stop button's label. So I'll click on the stop button, come over to properties, and down here under, let me take off the advanced properties. Down here under text, I'll say reset. And so now I've got the second most boring video game of all time. You can hit the go button and count the number of clicks, and then when you want to go back to 0, you can hit the reset button and start counting again. And it's like hours of entertainment. Yay, cookie clicker! Alright, so these are just, you know, getting our feet wet examples of working with this interface. And, you know, the thing to keep in mind is that when you do stuff over here, code is being created for you. So we're up to 88 lines of Java, right? And we only wrote, you know, about 4 of these lines for setting the text to count and incrementing count and so on and so forth. Most of this code was created for us, and this is entirely typical of you know, most modern programming environments. By and large, you're reusing a lot of machinery, and so there's interfaces to pull that stuff up and kind of do the boilerplate stuff, and then you do the particular unique part of whatever it is that you're trying to create. All right, other questions so far?
Is a action listener like a partial class? Is that how you're giving it a function there?
An action listener is a it's a method on most of these things like buttons. So let's look at JButton. So it inherits add action listener from the abstract button. And really all you have to do here is pass it an action listener object. And an action listener is an interface, which means that it's a framework for a class, and you need to write your own version of, in this case, one method called action performed. And so you could construct an action listener object. You could construct a class that implements this interface, write your action performed method, and then construct an object of that class and pass that as the argument to add action listener. But there's this shortcut, right, which is called an inner class, where you actually create that class right inside here at the place where you want to pass that class as an argument to this method. And I've got some sample code I can toss up later on to work through the details of that, but we don't need that for now because, you know, these tools will create this for us, and it really just kind of painlessly, you know, if we go to action performed, it takes us right down to the routine, and we can just put our code right inside this block.
So it's just an inline class that you're implementing action listener interface.
Exactly.
Gotcha. I've never seen that done in any other language. That's cool.
Yeah, it is kind of neat. The alternative is you know, writing lots of little tiny classes that have one or two methods in them, and having to name them and then reference them inside here and so on. So that's kind of a nice simplifying.
C# does it a lot if you do like UI stuff.
Cool.
I'm sure it does. I've just never seen an example of it like that.
Yeah.
All right, so over here, you know, you've got a hierarchy of components, right, or objects. So the top level is this JFrame, which is named, let me get rid of these. So I always have trouble finding this. Well, somewhere in here is the name of it. Anyway, this is a JFrame, and it includes a content pane, right, which is called content pane. It's a JPanel, so that's the class it comes from. This is the name of it, and then on that content pane we have three other objects. There's a thing called myText, which is a JLabel. There's a thing called button go, which is a JButton, and there's a thing called button stop, which is also a JButton. And each of these things, right, has different properties associated with it. You can change, you know, the background color, the foreground color, the font, the horizontal alignment of the font. Do you want it to be centered? Do you want it to be on the left? and so on and so forth. Huge amount of flexibility, right? So the dialogue class we used in 224 was a pretty quick and dirty way to make graphical interfaces from Bash. This is, the kind of thing that would be used to build dialogue, for example. And it gives you, absolute control over pretty much all aspects of your interface, the look and feel of it, but also, the behavior of it. And so, for example, with the J-frame, I can add event handler and let's say component resized. And in here I'm just going to print a message saying I just changed size. So if I run this, it'll say I just changed size a few times in the beginning because this thing begins its life, very small, and then the set size method changes it. And so moving this around has no effect, moving the mouse has no effect. But if I grab a corner and I adjust it, right, this method is being called continually. And what I could do in that method, I could print a message saying I just changed size, or I could move around my buttons based on the current dimensions, or I could flash the screen in some horrifying color to stop the person from resizing the window, or I could resize the windows to some default size to make it really annoying, or whatever I want, right? But pretty much everything that can happen to a window, to a component on a window, and so on, we have the ability to respond to that, to be notified when something happens and then to take some action. And so a lot of what's going to happen in PA 4 and 5 is going to be sort of exploring the possibilities, exploring these components, not completely because they're huge, but getting some ideas what kinds of things we can do, and then thinking about that in terms of, so what do we want to do for this next programming assignment? How would we like it to look? How would we like it to act? And then messing around with the components to make that happen. All right, so we got a little under 10 minutes left. Let me talk a little bit more about Eclipse itself. So Eclipse, depending on what you like, can be really cool or can be really annoying. So for example, as you're typing system.out, well, system, it's highlighted something above it, it's put a red line underneath, there's a red X over on the side, and it's all freaked out because this is a syntax error, right? Because I haven't finished typing. So if I hit the period, I get a pop-up, and it's showing me, a number of things that could come after the word system, period, including, error and so on and so forth, and presumably out, but I don't actually see out in here. So I can continue typing O, there's out, U, and I've got a little description over here of the standard output stream, but I can ignore that and type T, and then I can hit a period, and now I get a different pop-up, and I can say print line, and it tells me it's a syntax error, and I hit a parentheses, and it fills in a right parentheses and tells me there's a syntax error. And I can type a double quote, and it puts in another quote. And if I keep ignoring it, I can type that closing quote, I can type the closing parentheses, and I can type the semicolon. And when I look up, everything is great. But this can be nice because, for example, I've got this component event called E. I could say E period, and see all the different things that I could call from E. I could say get ID, I could say hash code, I could say get the source. And so sometimes, if you don't want to look at your documentation, you just want to see what kinds of methods could I call from this object, you can use this auto-completion feature to make your life a little easier. But if you pay too much attention to it, I've got a syntax error here, I've got a syntax error way down here, because it's assuming, that I'm done typing, and it's saying, hey, if you stop right here, you've got some errors. So if you like Notepad, if you like moving around with arrow keys, you can do this and totally groove. If you don't like that, I suggest taking a look at vrapper. That's V and then RAPPER. Just click on that, and it's from vrapper.sourceforge. Click on the stable, and you'll see something here. There we go. Alright, this is the Eclipse update site for stable vrapper releases. Add the remote site. So I'm going to right click and copy the link address. Alright, here's what I'm going to do. I'm going to go into help. I'm going to say install new software. And where it says work with, I'm going to say add. And I'm going to put in that URL. And now I can see vrapper. And so I'm going to click that, and I'm going to say next. And next, and I'll accept the license terms, and I'll say finish. And I'm just going to trust everything because I'm a trusting person. And then I'm going to have to restart. And I'll save my changes. And this is going to give me VI capability inside Eclipse. And if you like VI, this will be pretty good. And so I've got a little icon over here for vrapper. If I click that, it will disable it. But if I leave that button pressed, I can do things like, 10DD to delete 10 lines. And I can do a Shift P to put those lines in. And I can do a Shift D to delete to the end of the line and add something else in there, and a Shift U to undo the last change, and so on and so forth. So this is VI functionality, and if you prefer editing in VI, vrapper is a pretty good way to go. The one caveat is there are some keyboard shortcuts, like Control D, which normally moves down half a page, is hardwired to delete the current line, and that's a bummer. So if you're going to do this, go into Window Preferences, come up here and search for shortcuts. No, search for keys. And under keys, here's all the bindings to different keystrokes. So sort this by binding. Come down here to the controls and get rid of any that you don't like. So for example, Control D inside the console window means end a file. I like that, right? I want to hit Control D to say I'm done feeding input. But I don't want Control D to be a shortcut for delete line when editing text. So I'm going to select that and I'm going to say unbind. And then there's a few of those. Control F, we can unbind that if we want, because Control F goes forward a whole screen. Control G is used to see what line you're on, and so on. So you can customize this how you want. Control J joins two lines, so we could get rid of that, and so on. And now if I do a Control D, it moves down, and Control U moves up, and so on. So that's an option. Play around with this, right? You're gonna be in this environment for the next 5 weeks. Some of the courses at WSU, you'll be required to use Eclipse. Projects at work, projects with other people, you might be required to use it. So it's useful to dig into enough to be somewhat fluid in it. But you could take three online courses in it and barely scrape the surface of everything that's inside here. And then you get to your first job and they say you have to use IntelliJ, and so you got to learn a whole new IDE. So find a balance point. All right, that's all I got for today. So Thursday we will take a look at PA4, and we'll dig deeper into some components, and then I want to talk about how we actually do graphics on these components. And so we'll go back to looking at this idea of a raster scan and see how we draw pictures by lighting up pixels and so on and so forth. So we'll do all that Thursday. Come by office hours Thursday if you got questions. Otherwise, have a great day, and I will see you next time. All right, thanks.
Thank you.
Have a great day.
Thanks, you too.